Hey, ladies and gentlemen, the first real problems that you're going to see in homework today look like this. They're going to give you a table and they're going to ask you to determine if it's exponential or if it's a linear relationship between x, the independent variable, and the dependent variable y. Okay? So you know how much I love Desmos, right? Let's just look at a line. What do we remember? What do we know about lines? Well, the equations sometimes look like this, right? Slope-intercept form. And, here's the y-intercept, here's the slope. Well, we're not given the equation on today's homework problem. We're given a table of values, right? And so when you look at a table of values for a linear function, it's going to be increasing or decreasing by the same amount. We're adding or subtracting the same amount. So the key is add or subtract. Is that what's really going on here? Well, let's figure it out. Okay, so I'm going to go like this. I'm going to say, well, how do I get from 4 to 8? I'm adding 4, right? How do I get from 8 to 16? I'm adding 8. How do I get from 16 to 24? Adding 8 again. Now that's kind of weird, right? Like this one added 4, but this one added 8, and then it adds 8 again, and then it adds 16. What the heck? Well, look, another thing we also want to pay attention to is, are the x values going up by the same amount? This is the run part that we're concerned with. This is the rise part that we're concerned with. Well, this doesn't look linear, right? I mean, it's not adding or subtracting the same amount. So before we declare that it's exponential, because that's our main focus today, let's study exponential functions for a second, right? We know it's not linear. Let me put that down as clear as possible. Man, this baby's not linear because it should be going up by the same amount every time, right? Isn't that what linear functions do? Or go down, right, depending on the slope. This one's going up by 2, up by 2, up by 2, up by 2, up by 2. Now, if we jump in x values, like let's say we go up instead of to 5, we go up to 8, that could be a little deceptive, right? So you have to find the slope here. You'd have to go, okay, what's 19 minus 11? That's 8. What's 8 minus 4? That's 4. So 8 divided by 4 gives me 2. Oh yeah, this is the same, average rate of change between these 2 points as it was between any of these other points up here, right? So you have to be careful a little bit with the x's. But like I said, let's go down here and look at an exponential function, because maybe this guy over here is exponential. All right, so what's going on here? We got 1/3, then we've got 1, then we've got 3, then we've got 9. Wait a minute, what's happening here? Let me try this here real quick. Let me see if I can write on this for just a second. So I'm multiplying by 3 to get to 1. I'm multiplying by 3 to get to 3. I'm multiplying by 3. Do you notice how we're multiplying by 3 every time? Right? So let's turn on the graph and see what that guy looks like. Oops, I gotta go back to my mouse here. Turn my graph on over here, and let's turn this guy off. Okay, so we're going to turn the line on. We're going to turn the exponential function on. Okay, so this is what exponential functions look like. For sure, I mean, these points are definitely on the exponential function, right? And you notice the base is what we're multiplying by each time. We're multiplying by the same amount each time. So if we go back over and look at what we had going on over here, we know it's not linear because the difference wasn't the same every single time. So let's investigate if it's multiplying by the same amount each time. Well, we're multiplying by 2, then we multiply by 2. Ooh, I'm feeling good about this. Oh, shoot, man. Looks like I'm multiplying by 1.5. Oh, no. It's supposed to be the same every time, right? It's supposed to be exactly the same. Here, what the heck am I multiplying by? Well, one way we could do that is we could go 40 divided by 24 to figure out what we're multiplying by. I think 8 goes into here 5 times. 8 goes into here 3 times, right? And so this is like 1.6, right? 1.6 repeating. So it's not a common ratio every time. If it was 2 every time, the base would be 2. If it was 1.5 every time, the base would be 1.5. It would be like this. It'd be like y equals 1.5 to the x power. But it's definitely not that, right? It's definitely not it's not 2 to the x. It's not 1.6 to the x, because it has to be the same the entire time. So this one would be a neither situation. You know, it's not linear and it's not exponential. Those are our two options in the homework at the beginning of our assignment, okay? So let's go over here and let's look at one of these guys. Well, starts off kind of confusing, like 7, 6, but how do you get from 7, 6 to 7? Well, it looks like if I took like 7, 6, and I multiplied it by 6, the 6's would cancel out and I get 7, right? Okay, how do I get from 7 to 42? Okay, so 7 times 6 would give me 42. Now, this might be a little confusing, like trying to just guess. So, like I said over here, you know, if the numbers are a little tricky, you can take 1 divided by the previous term to figure out if there is a common ratio. So if I do 42 divided by 6, or 7, excuse me, I'm thinking ahead, I get 6, right? Oh, that was what I was multiplying up by, 7, 6 by 6. So this is my common ratio so far. This is called our ratio, our common multiplier. So if I do that same thing here, 252 divided by 42, okay, let's jump over to Desmos here real quick. Probably is going to be 6, isn't it? 252 divided by 42. Hey, look at that. It's the R, it's the 6 again, okay? So we got 6. I'm feeling like all of these are coming out to be 6. See how it's the same. Here, let's just do the last one. 1512 divided by 252. I don't think they're going to trick us on the last one. It does come out to be 6. So what does that mean? They also want us to come up with an equation, right? So our general equation for an exponential function is y equals a times b to the x value. So a is going to give us some kind of vertical stretch or compression. Now, on further problems, we're going to need to do maybe a horizontal shift or a vertical shift, and those will come into play, like putting a horizontal shift. You'll put it up there with the x, like x minus 3. Or we might need to do a reflection, but I don't think on the first bunch of problems we need to do anything super complicated. So what I'm going to do here is I'm going to go y equals, I know my r value. See, the r is actually the b value. So the b, the base, is going to be equal to your r value, right? So that was my 6. So I'm going to put down 6 here, and then I'm going to put an x up here. And then here's the thing, like if I put 0 in for x, okay, so what I'm doing is I'm trying to figure out what the y-intercept is. If I put 0 in right now for x, I would get 1. Is my y-intercept 1? No. My y-intercept is 7. So how do I transform 0, 1 to 0, 7? Well, this one's pretty straightforward. I need to multiply by 7, right? So what I need is a vertical stretch right here of 7, all right? So the first bunch of problems, I hope, are just like this. I hope they don't throw you any massive curveballs. I mean, the first problem asks you something maybe a little silly. Maybe I should have deleted it. It asks you to do something like, hey, raise 3 to the 1.234 exponent, or raise it to the 3.14 exponent, right? I mean, they just want you to see if you know how to do this on Desmos. You guys know how to raise something to a power. So good luck with the first 6 problems. I hope you find them doable and clear. Thank you.